I do. It's on the table. All right, good folks. Today is Friday, the 24th. Here on Tuesday, teacher absent. Nothing is written there. Teacher absent. Nothing is written there as well. Today is Friday. We're going to work on making sure that the warm up and the homework is completed so that we can submit. Okay, I'm going to finish the foldable. And then if you didn't get the opportunity to complete the review quiz, then please, that is when you're going to use your laptop to complete the review quiz. All right, that's it. That's all. That's what's on the agenda for today. I'm going to pause to give you a chance to write. Okay, good people. We're going to look at the warm-ups first, please. Make sure that we have the right idea. We've already done, or we have completed this warm-up, Monday's warm-up, 37. Tuesday's warm-up, let's do that. Let's make sure that this one is completed, please. Okay, we're going to use distributive property. Yes, but you got to staple it, babe. It's none of those sheets are stapled, okay? All right, so we're going to use distributive property first. If you hadn't already done this, let's please do this at this time. We're going to do distributive property first. So we're going to multiply. Let's see, I need some more lead. We need to multiply the -6 to both numbers in the parentheses. So this is going to give us a -6x. We're going to multiply a negative times a negative, which is a positive. Multiplying a half is the same as dividing by 2. So that's a +3. Bring down the equal sign. Bring everything else on the other side of the equal sign down. So distributive property goes first. Once we have completed distributive property, we need to combine like terms on each side of that equal sign. On this side of the equal sign, these terms are not alike, so you cannot add them. On the other side of the equal sign, we do have like terms. That's 3x and -9x. What is 3x minus 9x? -6x. Very good. And we're going to bring down the +3 and bring everything else down. Okay. We notice that both sides are exactly the same. That means that the variables are going to cancel out because we have to add or move the variables to the both sides, which means that we have to add 6x on both sides, which is going to cancel out the x term. The x terms cancel out, and on this side we're left with 3, and on this side we're left with 3. This is going to be a true statement. 3 is equal to 3. So because the variables cancel out and both sides are equal to each other, this is infinitely many solutions. Okay. Questions? I'm going to pause for the calls to give us a chance to write, and then we're going to move on. All right, let's look at the second problem on Tuesdays, or really Wednesday's warm-up, because we only had a 4-day week. It says solve and answer the question below. We have 4. What's number 2, baby? 4 more than, this is plus, a number. It doesn't tell us a number, so let's use a variable. Is, that's equal to, we got 14 less than. The words less than means that you're going to subtract 14 from something. So it's going to be the number first minus 14 because you're using the words less than. So we know it's going to be minus 14. Okay, what's going to go here? Less than 3 times the number. And remember, they didn't say a different number, so we're going to use the same variable. We infer that it's the same variable. Okay, it's the same number that we don't know. So this is going to be 3 times x minus the 14. This is the equation. Any questions about how I came up with that equation? So now we're going to solve this equation. First is distributive property. We don't have distributive property on either side. Sit up. Now we're going to combine like terms. We can't combine these, nor can we combine those. So now we're going to move the variables to the same side. I'm going to move the smaller 1x to the other side by subtracting 1x from both sides. When I subtract 1x here, on this side of the equal sign, I'm left with 4. Bring down the equal. When I subtract 1x from 3x, I get 2x. Bring down the minus 14, excuse me. I'm going to isolate the variable now. In order to isolate the variable, I must first get rid of all the numbers that are not directly attached by multiplication or division. So I'm going to get rid of the minus 14 by doing the inverse, adding 14 on both sides. When I add 14 to this side, I get 18. Bring down my equal sign, bring down my 2x. Now I'm going to divide both sides by 2, and I get x is equal to what number? 9. Okay, there's only, how many solutions? There's only one solution to this problem. And that one solution is 9. I'm going to pause for the calls. All right, let's move on. Okay, here's the next problem. Okay, I'm going to give us a minute and a half to complete this one. And then I'm going to give us a minute and a half to complete the second one. I want you to do 39 on your own, please. All right, let's see how we did this one. Move the variables to the same side because there's no distributive property and there's no terms that I can combine on each side separately. So I'm going to move the smaller one by subtracting 4x. This is gone and I'm left with negative 8 on this side and I'm left with 2x plus 3. To isolate x, I'm going to subtract the 3 first. This is going to give me 8, 9, 10, 11, negative 11. Okay, then I have 2x. When I divide both sides by 2, what do I get? Negative 5.5. Raise your hand if you got that right. Perfect. How many solutions? It's only one solution. And the solution is 5.5. Okay, any questions? Yes, baby.
I did it the other way, but I got the same.
That's okay. It's more than one way to do something. Okay, as long as you use math, okay? Let's do the second one. Was anyone still writing? I'm sorry. Okay. Let's look at the second one. You're going to do distributive property first. When you're multiplying by a third, that means that you're going to be dividing by 3, okay? So when I divide negative 6x by 3, that gives me a negative what? Come on, y'all. Negative 2x. When I divide a negative 9 by 3, that gives me a negative what? 3. Any questions about that part? Samaj, are you okay with it? Okay. Bring everything else down. There's no distributive property on this side, okay? Second step is to combine like terms on each side separately. Let's look at this first side. We cannot combine these terms, so we don't. On the other side, we can combine negative 3 and negative 2 together because they are like terms. What's negative 3x minus 2x? Negative 5x. Bring down the net minus 15. Next step is to move the variables to the same side. Okay, I'm going to move the smaller one. I'm going to move negative 5 by adding 5x to both sides. This is going to give me a positive 3x. Minus 3 is equal to this negative 15. Now I'm going to add 3 to both sides to isolate the variable x. James, do you see what I did? You sure? Okay. This is gone, and I'm left with 3x is equal to a negative what? 12. I'm going to divide both sides by 3, and x here is equal to what number? Negative 4. How many solutions are there? It's just one solution, and that one solution is negative 4. Raise your hand if you're still writing. Go ahead. I'm going to pause for the calls, babe. Let me know when you're finished. All right. The last warm-up, let's see what the last warm-up was. Okay, completely do the last warm-up on your own. I'm not going to go over that. I'm going to give you about 3.5 minutes to complete the last warm-up, okay? Do that one completely on your own. I'm not going to go over this one, okay? Guys, a helpful hint, if you forget how to do this right here, remember you multiply the top, divide by the bottom. See, 3/4. This is 8/1. So this is 24. Oops, Miss Reyes, sorry, y'all. This is 24 divided by 4. What's 24 divided by 4?
6.
So this is 6, -6 here, okay? We do the same thing for 16. It's going to be 3/4 times 16/1, okay? So you multiply 3 times 16 and divide it by 4. All right, guys. Okay, let's move on. I've already given you homework help for Monday. You should have already completed your Monday. So let's look at Tuesday, please. Let's look at Tuesday. This is the one that I sent a message to tell you to do for homework on Wednesday. So let's look at the diagram. It says the domain. What are your possible domain values? So your domain is talking about your x, and you're talking about the width. So my smallest x value is going to be here at -10. Okay, then it goes all the way to 10. So it goes from -10 to +10. -10 is the smallest, and it goes all the way up to +10. Put x in the middle. Less than equal to, less than equal to. Okay, why is it equal to, Ms. Reyes? Because these are closed circles on both of these. If they were open circles like this, then you wouldn't include -10 or 10 if it was on an open circle. But because these are closed circles, even right here, even though this is an open circle, down here is a closed one. So this x value is still included. Even though this is an open circle here and this is a closed one, this x value is still included. All of these x values are included because this is a solid line here. Even though it's an open circle, it's a closed circle down here. Another solid line from here to here, a closed circle. So the graph is still going from -10 to +10. Your range. Your range is talking about your y values. This is the height of the graph. When you measure height, you start from the bottom on up. So Masha, we're going to start from the lowest point of the graph to the highest point. The lowest point of the graph is down here. This lowest point is -1, 2, 3, 4. This is -4. So it's going from -4, and the highest part of the graph is right here at +1, 2, 3, 4, 5, 6, 7. And it's going all the way to +7. But this +7 is an open circle. So it's going to be no equal to sign. So put y in the middle, less than equal to, because this is a closed circle down here. But this is an open circle at +7, so it's just less than. Because 7 is not included as an answer because it's an open circle. Okay? Rarely, we're really not asked if it's relative, max, and min. We're really not asked those questions, so I'm just going to mark that out. But we are asked for intervals of increase and decrease. Okay? When you're looking for intervals of increase and decrease, this is where it's decreasing. So you're looking at your x. Your x value from -10 all the way to 0, it's decreasing. So that goes over here. From -10 to 0, the x value, your y is decreasing. So from x, when x is -10, all the way to when x is 0, this is where your graph is decreasing. Less than equal to, less than equal to. This is where it's decreasing from -10 to 0. This is where the graph is increasing from 0. Sorry, let me move this. From 0 here, it's increasing all the way up to 1, 2, 3. From 0 to 3. This is an open circle, so it's just less than. This is also an open circle, so it's just less than. This is an increase. This is a decrease. And it's decreasing from 1, this is 3, 1, 2, from 3 all the way to 10. So from 3 to 10, it's decreasing. Less than equal to, because it's a closed circle. Less than equal to, because it's a closed circle. And these are your levels of increase, decrease, 2 decreases, and 1 increase. I'm going to pause for the calls. All right, here we go. Let's do this. Remember, f of x is equal, it's the same as saying y. Whatever number is in the parentheses, that's your x value. Whatever number is here is your y value. So here, they give you an x value because this is the number that's in the parentheses. X is equal to negative 8. They're asking you, what is your y? Because y is missing, okay? Y is missing. So let's look at the graph and find negative 8 on the x-axis. Negative 8 on the x-axis is over to the left. 1, 2, 3, 4, 5, 6, 7, 8. This is negative 8. Go to the line. The line is right here. What is the y value?
Negative 1.
Negative 1. This is your answer. This ordered pair is negative 8, comma, negative 1. Let's look at the next one. The x value is missing, so they're asking you what is the x when the y value is equal to a negative 3. They don't give you x, but they give you y this time. So now you go to the y-axis and look for negative 3. Negative 3 on the y-axis, positive 1, positive 2. I'm sorry, negative 1, negative 2, negative 3. Go to the line. The line is right here. What is my x value here?
Negative 3.
1, 2, let's see. 1 is just 2, negative 2. See if you can do this last one on your own, okay? Pause for the calls. All right. They're giving you the x value. The x value is 5. They're asking you for the y. So you're going to find 5 on the x-axis. 1, 2, 3, 4, 5. Go to the line. What is the y value here?
3.
It is 3. Raise your hand if you got that right. Perfect. Okay. Anyone still writing? You still writing, baby? Sit up. Sit up. Elizabeth, y'all sit up. Sit up. All right, Sarah. I've been getting y'all confused, Lord. All right, here we go. X plus 3y is equal to a negative 9. Now we're going to write this in slope-intercept form. This is a linear equation. To write it in slope-intercept form, that means you're going to get y by itself. You're going to move the x value first. Subtract x on both sides. This is gone, and we're left with 3y is equal to negative x minus 9. You could write minus 9 first, negative 9 minus x. It doesn't matter, okay? I just choose to write it so that x comes first. Now we're going to get rid of the 3 by dividing everything by 3. 3 divided by 3 is going to give us 1y. Bring down the equal. This we're going to keep as a fraction, negative 1 over 3x. And we can simplify negative 9 over 3. What's negative 9 divided by 3? Negative 3. This is the equation that we're going to graph. When you graph the equation, you're going to label your M and your B. Which one of these numbers, the two numbers, this one or this one, which one of those numbers is the M? Negative 1 over 3. Top number is labeled as rise. What's the bottom number labeled as? Run. Then negative 3 is B. Now in order to graph, we're going to find B on the y-axis. The starting amount or our y-intercept is negative 3, so find it on the y-axis. Negative 1, 2, 3 is here. This is where we start. We're going to use rise over run to put points on the line. Our rise is a negative 1, so we go down 1. Our run is a positive 3, so we go to the right. 1, 2, 3. Down 1 and to the right. 1, 2, 3 would be over here. If we want points in the opposite direction, then instead of going down 1, go up 1. Instead of going to the right 3, go to the left. 1, 2, 3. Up 1 to the left. 1, 2, 3. Until you run out of space. Now you connect your ordered pairs. This is your line. Any questions about that? Okay. Please do the next two on your own. Write it in slope-intercept form and then graph it. Pause for the cause. All right, let's look at Wednesday, please, because this is super duper important, okay? All right, the formula that you use for average rate of change is the same as the slope formula. The slope formula is y2 minus y1 over x2 minus x1, okay? When they're asking you to find the rate of change when given intervals, these are the intervals that they're talking about. These are your x values. So they give you two x values. The first x value is 1, and the second x value is 3. Sorry, first x value, second x value. Please write that in. They give you two x values. You use the table to find the other x value. The other y value. Okay, so find where x is 1. X is 1 is right here. What's the y value when x is 1? 40. What's the y value when x is 3? 18. Any questions about how I found those two ordered pairs when given the interval? So now they want you to find the rate of change. So we're going to rewrite the slope formula to figure out what the rate of change is between those 2 points or intervals. What do we put on the top? What minus what? 18 minus 40. What do we put on the bottom? 3 minus 1. Okay, let's type that in. What is 18 minus 40? That's going to be a negative what? Negative 22. What is 3 minus 1? That's positive what? 2. Let's reduce. Negative 22 divided by positive 2 is negative what? 11. So the slope between these two intervals is negative 11. I'm going to pause for the cause. All right, see if you can do this second one on your own. We're going to mark out these. Please do number 2. All right, good people. I'm going to show you how to do the one on the bottom. I'm going to mark out, we're just going to do one set instead of 2. It's giving you 2 sets of intervals. I'm just going to do one set of interval, okay? I'm just going to do one set, just this one. So they're giving you 2 x values. Where I get negative? I don't know, y'all. I'm sorry. And then 2. Those are your 2 x's. You have to figure out what your y's are. We're going to use our calculator to do that. They give you an equation, so you're going to substitute the x value into the equation to figure out what the y is. So the first x value we're substituting into this equation is 1.9. So we have, I'm going to put 1.9 in parentheses and square it because that's a part of the equation, plus 5 times the 1.9, close the parentheses, then put plus 6. So all I'm doing is substituting 1.9 into the equation, which gives us 19.11. I'm going to do the second. I'm going to substitute 2 now. So now I have 2 squared plus 5 times 2 plus the 6. And what does that give me?
17.
That gives me 20. So now I use the slope formula, y2 minus y1 over x2 minus x1. Okay? What sheet is this one, too? Okay, good. See if you can find the slope here. All right, and then after you finish that, please put your calculator up, and you're going to hand me this packet on the way out the door. So we're not going to do these. We don't have time to do those. No, we turn it in today.
Oh.
No, you got other stuff that we got to do. Mark it out, please. So finish this problem, and we got the show must go on, even when I'm not here. It's got to move on. We'll cover this next week. We hadn't done it yet. I can't give you something that I hadn't done. I'm going to grade based on what I just given you. If you don't have that, you up the creek. I just said no, baby. Yes, because you did Monday. Yes, you did, because I already gave you Monday. We already did Monday, y'all. I sent the homework. We already did Monday. Miss what? Shh, I don't know what you thought. Look at this, Monday. I don't want to ask your daddy. He ain't in my class. What the world? I don't know why y'all think I would like to do that. Y'all go through them. I don't have to. Yes. Shh. It is an excuse, though. What you need, baby? I do. I just want it. Shh. Yeah, I just want it. All right, but you need to make sure that you have that. I'm going to take it on the way out. Please pick up your calculator. Y'all know what I'm saying. Your cell phone.